Think of Docker as a single shipping container. It packages everything you need for your app to run. Now, Kubernetes, it's the entire port, managing thousands of containers and deciding where they go, how they run, and what happens when something breaks. But how do these two actually work together? Docker is a platform that lets you build, package, and distribute applications in isolated environments called containers. A container includes everything your app needs: code, runtime, libraries, and dependencies. Think of it like creating a portable, lightweight virtual machine, but without the overhead. This Docker file tells Docker to use a Python image, set up a working directory, copy the app files, install dependencies, and run the app. Kubernetes is a container orchestration platform. Once you have containers, Kubernetes manages them across multiple machines. It handles scaling, load balancing, and self-healing. Imagine running 1,000 containers across 100 servers. Kubernetes makes that possible. This configuration deploys 3 replicas of a containerized app and ensures Kubernetes keeps them running, scaling them as needed. Docker creates the containers. Kubernetes manages and orchestrates them. You can run Docker containers without Kubernetes, but for large-scale distributed systems, Kubernetes is essential. Alright, let's break it down with more technical detail. You already know Docker packages apps into containers. Kubernetes orchestrates those containers. So how do they fit together? Docker is the building block. Its core role is to package and run applications in isolated environments known as containers. The Docker file is a text file that describes how to build your container. It defines the base image, for example Python or Node.js, installs dependencies, copies files, and sets commands for the container to run. The Docker image is the result of the Docker file. The image contains everything needed to run your app, including code, libraries, system tools, etc. The Docker container is a running instance of a Docker image. Think of it as an isolated process that can be run anywhere on any system that supports Docker. Docker allows developers to create a consistent environment for their apps. You can ensure your code runs the same way in development, staging, and prod. Kubernetes is about managing this scale. It's a powerful orchestration system for Docker containers and provides features that Docker alone cannot handle at scale. Kubernetes groups one or more Docker containers into pods, and a pod is the smallest unit in Kubernetes and shares the same network and storage, which makes it ideal for tightly coupled applications that need to communicate with each other. Kubernetes uses deployments to manage the desired state of your app. A deployment defines how many replicas of a pod should be running, and Kubernetes ensures that number is maintained. So in short, a deployment manages a set of pods to run an application workload, usually one that does not maintain state. And this deployment provides declarative updates for pods and replica sets. A replica set ensures that a specified number of pod replicas are running at one time. So you, as a developer, describes the desired state in a deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. And the deployment controller is a control loop that watches the shared state of the cluster through the API server and makes changes attempting to move the current state towards the desired state. Kubernetes can automatically scale the number of pods based on traffic load. So horizontal pod autoscaling scales by adding or removing pods. HPA starts new pod replicas to serve the additional traffic. When demand decreases, HPA scales the workload back down. And HPA can scale based on one or more metrics, including HTTP request throughput, message queue size, CPU utilization, memory utilization, actual resource usage, such as when a pod's CPU or memory usage exceeds a threshold. Kubernetes also automatically balances incoming network traffic across pods, distributing requests so no single container becomes overloaded. And if a container inside a pod fails, Kubernetes restarts it to maintain the desired state. If a node crashes, Kubernetes reassigns pods to other available nodes. The TLDR is that while Docker runs the containers, Kubernetes handles the orchestration, deploying, scaling, and managing hundreds or even thousands of containers across multiple servers. It's the ultimate tool for running complex and distributed applications. So here's a simple workflow of Docker and Kubernetes. Developers use Docker to package the application into a container, including all dependencies. The Docker image is pushed to a container registry like Docker Hub or Google Container Registry. Kubernetes pulls the image from the registry and deploys it as a pod. Then, Kubernetes will monitor the traffic and scale the pods horizontally, adding more containers as needed. It will also ensure the incoming traffic is routed to healthy containers, and if any container crashes, Kubernetes automatically restarts it to ensure that the desired number of replicas is running. The ultimate question is, why use Docker and Kubernetes together? Docker alone is perfect for single container apps and local development environments, but when you need to manage and scale many containers, Docker alone falls short. Docker and Kubernetes is essential for production environments where automated scaling, failover, and management across multiple machines is critical. So Docker itself simplifies building and testing apps, while Kubernetes ensures that those apps run reliably at scale. Together, they're the backbone of modern cloud-native applications.